Hello everyone, today we are introducing an important field of mechanical engineering science, and to begin with we are going to discuss simple stress. We must note that in any engineering structure or mechanism, the individual components of the structure will be subjected to external forces or loads arising from the service conditions or environment in which the component works. If the component or member is in equilibrium, the resultant of the forces will be zero. But nevertheless, these forces together place a load on the member which tends to deform that particular member and which must be reacted by internal forces that are set up within the material. Now, if a cylindrical bar is subjected to a direct pull or push along its axis, as shown in the figure below, okay, here it is subjected to a pull and here it is subjected to a push. Okay, so it is said to be subjected to tension or compression. That is, if the forces act towards each other to push or shorten or reduce the length of the object, then it is under compression, and the stress that will be produced will be compressive stress. If it is subjected to a pull and therefore there is an increase in its length, then it has been subjected to tension and therefore the stress that it is subjected to is called tensile stress. Typical examples of tension are forces present in towing ropes or lifting hoists, and the compression. An example can be looked at on the legs of a chair, that as you sit on it, the legs of the chair tend to be in compression, and therefore the stress that will be set up in those legs will be compressive stress. And another example can be the pillars of a building, because these pillars support a weight which is on top of them, and therefore they are always in compression. This is the kind of loading that we are talking about. This one is the axis of the object. So this is in compression, this is in tension. Therefore the stress will be force over area, or what we can call load over the cross-sectional area. Now let us look at the units of stress. Units of stress, having said that stress is load over cross-sectional area, the load is always in newtons and area is in square meters. However, in engineering, the loads are always heavy, and therefore it is rare for us to have just mere newtons per square meter, but we can always have bigger units like kilonewton per square meter, meganewton per square meter, and giganewton per square meter as the stresses in such kinds of scenarios. Then let us look at the types of loads. As we know, in engineering there are different ways in which the load can be applied to a member. You can have static loads, and these are loads which are non-fluctuating. For example, the weight of a building, so the weight supported by the building, just when we total up its weight, that kind of load on the foundation is the dead load. Now let us look at the live loads, and these loads are produced whenever there is a maybe for example, in a building, when people enter or occupy the building on that particular day, when they move out, they are subjecting it to live loads. Even when a vehicle crosses over the bridge, the live load is set up onto the structure due to the truck or vehicle that is crossing over the bridge. There are also impact loads which are caused by sudden blows. This can be, for example, a sledgehammer hitting a particular metal during maybe forging. You can also imagine of any other sudden or impact load which can be given onto an object, and therefore also be exhibited in the form of a sudden blow. There is also what we call fluctuating or fatigue or alternating loads. Now these are loads whose magnitude and sign will change with time. In other words, if you have a load varying over time within an object, it is going to cause a fatigue, and therefore the type of load will be called fatigue load on the object. Let's also discuss direct strain. If a bar is subjected to direct load and hence a stress, the bar will change in length. If the bar has an original length L and changes in length by an amount del L or sigma L, the strain epsilon produced is defined as direct strain will equal to change in length divided by original length, and this is equal to sigma L divided by L, which is the original length. Therefore the strain is going to equal to this amount. We must note that strain is a measure of deformation of the material and is non-dimensional because we observe that it is a ratio between quantities of the same units, and therefore this strain has no units. You subject this bar to tensile forces, you realize that there is going to be a change in length. So the strain will be the change in length divided by the original length of the object. If we need strain in percentage, we just can give it like this: sigma L, or change in length divided by the original length times 100 will give us the percentage. How about the sign conversion for direct stress and strain? We said if an object is acted upon by compression forces, then it is trying, the forces are trying to reduce its length. Therefore, compression or compressive stress is going to always be indicated as a negative, whereas the tensile stress is going to be indicated as a positive because there is a pull on the body and there is going to be an increase in its dimensions, especially along the length of that object.